we go. Greetings and welcome, friends of all ages. Today we're taking a look at exponential functions, homework, page 708. And here's question 13. It says, graph each exponential function or inequality. Now, this is somewhat intriguing. I might graph this based off of general concept at first. Let's see, did I accidentally close this? Where's it hiding? There it is. Thing of beauty. So yeah, let's see, that looks good right there. I'm gonna grab a little snapshot like so. Actually, you know what? I'm gonna go a little further back. Bam, right there is good. And just in general, y equals 2 to the x. Let me graph what that one looks like first, and then we'll graph this using an interesting strategy. Now, let's see, y equals 2 to the x would have been passing through there, and then at 1 it would have been 2, and then at 3 it would have been 4, because 2 to the 4th, and then at 3 it would have been 8, there we go, and then it would have been like a half and a quarter and so on. So like this purple graph is what y equals 2 to the x would have looked like. All right, so if I want to do y to the 2x plus 3, all in parentheses, so to speak, the x plus 3 is kind of grouped. So remember, like with parabolas or circles, like how we had like the x minus h all squared sort of thing going on, and that it would shift it in the opposite direction of this. I actually believe that this is going to end up being a shift 3 units this way for every point, if I'm not mistaken. So it should end up just being like a graph like this. Something like. Actually, it would have crossed through at 8 there, but you get the idea, right? So I believe that's one of the ways I could think about this, is it's the same graph as y equals 2 to the x, just shifted 3 units to the left. Did I say right? I meant left. Another way we could have done this is just with like a table of values, so to speak. Where I could plug in some nombres, -2, -1, 0, 1, 2. Actually, these ones are going to get big, but that's fine. So -2 plus 3 is -1, 2 to the -1 is a half. -1 plus 3 is 2, 2, wait, sorry. 2 to the first is 2, right? Yeah, all right, what was I saying? -1 plus 3 is 2, 2 squared is 4, and then 8, and then 16, and then 32. So yeah, so if I graph this way, -2, 2, and -1, 4, and 0, 8, and it does exactly what I had predicted it would.
Why is the y 2 next to -2? Where is that?
Because -2 plus 3 is 1, and 2 to the first power is 2. So yeah, so the cooler way I think to think about this, and we'll actually at some point do a section on families of functions, where you can actually translate them and stretch them and do all sorts of different things through this sort of tactic. So I just happen to know that, oh, this is a shift to the left 3 units, and eventually you guys will as well. Let's see, next and last question we'll look at for today is about aviation. It says, when kerosene is purified to make jet fuel, pollutants are removed by passing the kerosene through a special clay filter. Suppose a filter is fitted in a pipe so that 15% of the impurities are removed for every foot that the kerosene travels. So, write an exponential function to model the percent of impurity left after the kerosene travels x feet. So what we've got is, think about it this way. If it's 15% less, the percent that remains is 85% remains. Right? So that's going to be like my growth factor, but it's a decay factor in this case. So when I set this up, y, the amount left, would equal 0.85 to the xth power, where x is the number of feet, so to speak, that it passes through. So the more feet that it passes through, the less that remains for every foot. So it's like 85% after the first foot, and then 85% of that 85%, and then 85% of the 85% of the 85%, and it just would be exponential decay from that point on. Now it says to graph the function. So we could actually plug in some values for x, make a little tablet of values. So we'll do 0, 1, 2, 3, and 4 perhaps. So through 0 feet, what should it have? It should be 100% of its value, right? Would you guys agree? Yeah, makes sense. 0.85 to the first would be 0.85. 0.85 squared is 0.7225. That's not a 2. 0.85 to the third is, we'd be about 61% remaining, 0.6141. And then 0.85 times that value is 0.522. 0, not 1. There we go. So let's see. I'll grab a little graph paper here. How about, shall we? And so now that I've got my nice little graph paper here, I can plot some points. And so we have 100% at 0 feet, 0.85, and then 0.72. No, that's 90, isn't it? Yeah, that is. There's 0.85. Here's 0.7, so 0.72, and then 0.61, and then 0.522. And this is actually going to end up being, it's going to be asymptotic with the x-axis here. But theoretically, right, you would never get rid of all of the impurities, theoretically. But let's actually graph this for real here. 0.85 to the xth power. And yeah, you can see that that's kind of what we had there. I'll regraph it. And yeah, you can see that it is in fact asymptotic. So in order for it to even be like 10% of the pollutants remaining, it actually has to pass through like 13% or 13 feet of that clay filter. So yeah, depending on what quality you'd want, you'd have to pass it through a decent number of feet there. So so here, I'll even grab this little snapshot here, a little thing of buttes. Thing of beauty. So, what are some follow-up questions here? It says then, about what percent of the impurity remains after the kerosene travels 12 feet? So graphically speaking, I could kind of look at this here. And something like that. Algebraically, how could I figure that out? And yeah, and then do some calculating. And I do in fact get 0.1422. So about 14% of the pollutants remain after that 12 feet. And let's see, will the impurities ever be completely removed? And I just talked about that a little bit. Mathematically, if our world was infinitesimally divisible sort of thing, like if I could break it up into infinitely many small units, the answer to that question would be no. However, in real life, you could say kind of for all intents and purposes, an engineer might conclude that, yeah, that's, you know, it's going to be pure enough, right? And technically, our world cannot be broken down into infinitesimal parts. There is, what is it, 10 to the negative 32nd meters? I forget what it is the smallest possible unit. Because if you go any smaller than that, then particles actually lose what's called locality, and they are actually present throughout the entire universe and no longer measurable at a no longer have a location where they are. I don't know. Our universe is crazy, guys. That's all I'm saying. But yeah, so welcome to our universe. It is neither infinite or infinitely small, and there's no such thing as random. But mathematicians like thinking about these concepts nonetheless. So thanks for hanging out. Have a great day. Bye-bye.